This video is going to cover Chapter 7, Section 8, which is the applications of matrices and determinants. All three parts, the area of a triangle, determining if points are collinear, and all of the systems of equation using Kramers' method. Area of a triangle. So the way you can find the area of a triangle, if you are given 3 coordinate points, so for this to work, we need 3 coordinate points, 3 xy coordinate points. Then I would find the area by doing plus or minus, and I'll explain what that means in a second. 1/2 the determinant of a matrix that is formed by the x coordinates, the y coordinates, and then the last column is all ones. So what we'll do is we'll find that the determinant of this 3x3 matrix. We'll repeat the first 2 columns to the right and do our diagonals, and then back the other way, and then subtract the first minus the second. And you'll get the determinant, and then you'll multiply that times 1/2. And then sometimes that determinant is positive and sometimes it's negative. If it's positive, it will stay positive because area has to be positive. And if it's negative, you'll change the sign so that it is a positive number. So the plus or minus symbol indicates the appropriate sign that should be chosen to yield a positive area. So obviously we can't have negative area. You always want to make sure your answer is positive. All right, so example 1 says, find the area of the figure with the given vertices. Again, you have to have 3 sets, which we do. And then I'll write x and y, x and y, and x and y. So all the x's are in a line, all the y's are in the line, and the last one is straight down ones. So normally this would be our matrix, and to find the determinant of it, which is what that symbol is, we're going to duplicate the first 2 columns to the right here. And then do the diagonal top left, bottom right first. So -2 times 3 is -6, times 1 is -6. 4 times 1 is 4, times -1 is -4. 1 times 2 is 2, times 5 is 10. And then I want to add them together in the end. So I get -10 plus 10, which is 0. And then I go back the other way. So now the diagonal is going bottom left, top right. And this is 1 times 3 times -1, which is -3. -2 times 1 times 5, which is -10. 4 times 2 times 1, which is 8. Add those all together. -13 plus 8 is a +5. -5. And then I would do 0 minus a -5, which is 0 plus 5, which is 5. And then I want to do 1/2 that. So the area is equal to plus and minus 1/2 the determinant of the x's, the y's, and the ones. So I would do 1/2 of 5, which is 2.5 or 2.5. And it's already positive. If it wasn't positive, then I would change it so that it was. So the area of a triangle formed by these 3 points is 2.5, and we don't have a units, so it would be units squared. Okay, example 1, but letter B, says to find the area of this given shape. So this is actually a parallelogram. It's not a triangle. So I'll give you a second to think about how you could find it based on what we just talked about. Hopefully you were thinking that this parallelogram is formed by 2 triangles. So if I were just to find the area of triangle A here, and then area of triangle B here, and then add them together in the end, I'd get the area of the whole parallelogram. You could have divided them differently. I could have divided them across this way, which would give you the same answer. So I'm just going to go with what we did because I already drew it. I'm going to first find the area of that purple triangle. So it's going to be plus and minus 1/2 the determinant of these 3 points. So -3, 2, -1, -4, and then -5, -4. Fill in the ones And that's going to be the purple triangle. And then I'm going to come over here and do the teal triangle. Actually, I'll make it blue so it's a little bit easier to read. Plus and minus 1/2. Again, now I'm doing this top one, which is here, here, and here. -3, 2, 1, 2, -1, -4, and then 1, 1, 1. So the order of those points doesn't matter. Like I could have switched these two with these two, as long as the X's go in the first column and the Y's go in the second column, and you stick with each individual point on the same line or same row, you'll be fine. All right, so I'm going to come over here and do this one first. So I would rewrite the first two columns, -3, -1, -5, 2, -4, -4. And then diagonals this way. So -3 times -4 is 12 times 1 is 12. 2 times 1 is 2 times -5 is -10. 1 times -1 times -4 is a +4. So I'd get 2 plus 4, which is 6. And then go back the other way. 1 times -4, -4 times -5 is 20. -3 times 1 is -3 times -4 is +12. 2 times -1 is -2 times 1, which is -2. And I get 32 minus 2, which is 30. And then 6 minus 30 is -24. That takes the place of this whole part. So I get plus and minus 1/2 -24. That's going to be plus and minus -12. And I want to keep that area positive. So I change it to a +12. So that's the top, or that's the bottom left triangle of this parallelogram. And now I'm going to work the top one. So I would repeat the first two columns. And then diagonals, top left, bottom right first. -3 times 2 is -6 times 1 is -6. 2 times 1 is 2 times -1 is -2. 1 times 1 is 1 times -4 is -4. -8 minus 4, which is -12. And then go back the other way. 1 times 2 is 2 times -1 is -2. -3 times 1, -3 times -4, +12. 2 times 1 times 1, +2. And I get 12. So then I want to do -12 minus 12, which is -24. And the area is the 1/2, or plus or minus, sorry, 1/2 of -24, which is plus and minus -12, which is a +12, because I want the area to be positive. So hopefully what you know about parallelograms makes this clear that these should have both been the same. Okay, if I think about the fact that this is a parallelogram and I drew a diagonal, so this diagonal would be reflexive, meaning it would be on both parts of my triangles and they would be the same. And opposite sides are congruent in a parallelogram, which means this one would be congruent to this one would be congruent to this one, and I have two congruent triangles because of side, side, side. So that's one way. Obviously, there's other ways, but that would be one way to prove that those two triangles would be congruent. So actually, once I find my first triangle, I already know the second one. And then I can just simply add these two together. So 12 plus 12 gives me 24 for my entire parallelogram. Or just don't take the 1/2 at the beginning and you end up with the same answer. Just make sure that it is positive. So the benefit of doing it twice is obviously to check your work. It's really easy to make a mistake here. So if I had worked this one out and then I had gone and worked this one out and I got different answers, then I know something's wrong and I can double check my work. So if this is on your test, obviously I would say take the time and be careful with it. But other than that, if you're super careful the first time you know that answer's right, then I know I can just not cut it in half, and that's the area of my whole parallelogram. And again, this time we didn't have units, so it would be units squared. All right, the next part of the chapter, the section, and actually the last one we're going to cover for today, is testing that points are collinear. So again, a little bit of geometry review. The word collinear means that all 3 points lie on the same line. If 3 points lie on the same line, no matter what that line is, obviously they can't form a shape. This would have no area. So hopefully it makes sense that this would be 0, okay? If the determinant of those 3 points is 0, then they are collinear because they'd have no area. Whether or not you put the 1/2 of the front, if whatever's inside's at a 0, you would multiply by 1/2, you would get 0. So we just simply figure out if the determinant of these 3 points with the 1s at the end, just like we did for area, would be 0. If that's the case, then these 3 points lie on a line, which means that they are collinear. So example 2 says determine whether the points -2, -2, 7, 5, and 1, 1 are collinear. So I'm going to find the determinant of -2, -2, 7, 5, 1, 1, and then the last row is 1s. And if the determinant is 0, the answer is yes, and if it's not, then the answer is no. So I repeat those columns again to the right, the first 2 columns, and then I start my diagonals. So -2 times 5 is -10, times 1 is -10. -2 times 1 is -2, times 1 is -2. 1 times 7 is 7, times 1 is 7. So -12 plus 7 is -5. And then go the reverse. 1 times 5 is 5, times 1 is 5. -2 times 1 is -2, times 1 is -2. -2 times 7 is -14, times 1 is -14. So 3 minus 14 is -11. And the area here is the determinant is -5 minus the -11, which is 6, which means these points are not collinear. And while I'll obviously want to see your work, an easy way to check to make sure that you're right is by plotting these points. So I've pulled a coordinate grid in here, and I'm going to plot these points. -2, -2, which is here. 7, 5, which is here. And 1, 1. And you can see that while it looks like they are close to forming a line, there would be my straight line. So these 3 are not collinear, which is consistent with the information that we just found using the other method. So if this question was on your test, obviously I'd be looking for the work to show that it's not collinear, not just the graph. But the graph is a great way to check to make sure that your work is correct. All right, so that's where this video is going to stop. I'll do the second part of 7, 8 tomorrow. You can continue, or you can use the rest of the time to work on your assignment. Have a great day. So Kramers Rule is the last thing we're going to learn, not only for the chapter, but it's also the last method you're going to learn to find systems of equation solution. We're going to learn how to do it for a 2 variable and a 3 variable. So the first thing you have to do is figure out what the matrix is. So you're going to take your initial system, you're going to rewrite it in an augmented matrix so that if it was rewritten, it would have been the x's, the y's, and then the constants. If it's a 2 variable equation, right? 2 variables and 2 equations. And then you're going to do the determinant 3 times with the different combination of numbers. So I'm actually going to kind of flip around on what this notation says. The first thing we're going to find is what's called D. So there's a D sub x, and there's a D sub y when you're doing a 2 variable. And the D you find by finding the determinant of the columns that are the x's and the y's. So your x's and your y's will fill your D determinant. And then you'll actually do the determinant and get a single number. And then you find D sub x. And to do that, you take out the x's, and in their place you put the constants. So it has to go in the order of constants first and then the y's. So from what you got from D, you take out the x's and you put in the constants. And then for D sub y, you take out the y's and put the constants. So you'll put the x's and the constants.
constants from the original equation?
Correct.
Okay.
Yep. And then to find your x, you will put d sub x over d and simplify it. To find the y, you'll put d sub y over d and simplify it, and you'll end up with your xy combination. So you're basically doing a 2 by 2 determinant 3 times here, which on your test, so you're not going to get a question that just says find the determinant with a 2 by 2. You'll get it applied this way. And it will break it down. It will ask you for d sub x, d sub y, and then your final answer, which is your xy combination. All right, so let's work through it. So it says use Kramers rule to solve the system. First thing I want to do is rewrite my system as a matrix. So this would be 2, -3, -11, 1, 2, 12. And then I have 3 determinants to do. D, which is the x's and the y's, the first 2 columns, 2, -3, 1, 2. And I'm going to go back and do that determinant. D sub x, so for d sub x, I take out the x's and I put in the constants. -11 and 12 go in the place of the x's, and then the y's stay the same. And then d sub y, the x's stay where they go. I take out the y's and I put in the constants. And the order here is important, so be careful. Don't switch those around. With me so far? So now I just go through and do the determinant. Okay, some of you switched this around when you were either doing the determinant or you were doing addition. I don't know what you were doing. Make sure you do the multiplication and then the subtraction. So 4 minus a -3 becomes 4 plus 3. So D is 7. -22 minus a -36 becomes plus 36. This is 14. And 24 minus a -11 becomes plus 11, and I get 35. And then the x is d sub x over d, or 14 over 7, which is 2. And y is d sub y over d, which is 5. And my answer is 2, 5, written in that way. And just like every other system, it can be checked by plugging that solution back in. So now we know elimination, substitution, graphing, Gaussian elimination with back substitution, and Gauss-Jordan. And now we've added the 6th method, which is Kramers rule. Obviously, for the test, it's going to say solve using Kramers rule. Okay? But on a cumulative test or standardized test, and it just says solve a system, you can pick any way you want. And honestly, like, this takes a little bit of time, but as you're better at it, if these had like fractions that were like 17 over 5 and 42 over 6 or 42 over 5, it would be way easier to do it with Kramers rule than it would be to be doing that with elimination, because you're dealing with fraction the whole time. Whereas Kramers rule, you're always going to get a whole number for d, a whole number for d sub y, a whole number for d sub x. It's just the answer at the end, which would be your fraction.
You can do this with 3 by 3 as well.
That's what we're going to do next. Yep. Okay, so I'm going to let you work through this sample, and then that's next. The last part is a Kramers rule using a 3-variable equation. So you can also use Kramers rule to do the x's, the y's, and the z's. The difference, obviously, we up it a notch because there's 3 variables, which means every determinant has 3 columns, which means every determinant is a 3 by 3 determinant, where you have to add the first 2 columns to the right and do the forward slash and then the backward slash. Again, quiz, most people did pretty good on this. Watch your signs, and some people did like a handful, maybe 3 out of everybody that did it. Took columns 2 and 3 and wrote it to the right. Make sure it's column 1 and 2. Okay, you get a totally wrong answer if it's columns 2 and 3. So the same process happens. You're going to take your initial system, you're going to rewrite it as a matrix, and then your D value comes from the x, the y's, and the z's. The D sub x, I take out the x and put the constants in that first column. The D sub y, I take out the y's and put the constants in that column. And then the D sub z, I take out the z's and I put the constants in that column. Figure out all 4 of those determinants and then put the D of x over the D of y over the D, and the D of z over the D. So again, on a test, it's not going to say, here's a determinant, or here's a 3 by 3, find the determinant. You are going to do the 3 by 3 by doing Kramers rule. All right, so we're going to work through one. Directions to say use Kramers rule to solve. So we start by rewriting that system in matrix form. So this would be -2, 1. There is no z, so I have to put the 0 in its place to hold it. And then 1, 1, -1, -2, 2, 3, 1. Again, no z, so a 0, 6. So there's my x, my y, my z, and my constants. So the first one I'm going to find is D, which is the x, y's, and z's. The first 3 columns. -2, 1, 0, 1, -1, -2, 3, 1, 0. And then I'm going to find D sub x. So I take out the x's and in its place put the constants. 1, 2, 6, and then do the y's and the z's. And then I would do D sub y. So I leave the x's, take out the y's, put the constants, leave the z's. And D sub z. The x's, the y's, and the constants. And then go through and do the determinant for each of these. So I repeat the first 2 columns. Top left, bottom right slashes first. So this is 0, -6 plus 0, which is -6. And then go back the other way to 0 plus 4 plus 0, which is 4. And I get -6 minus 4, which is -10. And then I go to D sub x. Repeat the first 2 columns to the right. Zero minus 12 plus 0 is -12, and then go back the other way. 0 minus 2 plus 0. And I get -12 minus a -2, which becomes plus 2, -10. And then I do y. Mm-hmm.
Is it plus or minus?
When you do after you do the dashes. So each individual dash, I add the 3 from, like, so if I'm going this way, and then I add those 3 together, and then I go back the other way, and I add those 3 together, but then I do the first minus the second. So think just like that Jesus fish, right? The little I is your minus. You do it the same order. You're welcome. So here I would get -2 times -1, which is 2, times 6, which is 12. 1 times 2 times 3 is 6. And then 1, that's 19. And then go back the other way. This would be -3 minus 4 plus 6, -7 plus 6, which is -1. And then 19 minus a -1, which becomes +1. And d sub z is 20. So the test is going to break it down the same way. I gave you a little space in order to find d. I gave you a little space in order to find d sub x, d sub y, and d sub z. And then make sure at the end you figure out what your x and your y and your z are. So the x would be the d sub x, which is -10 over d, which is also -10. That's 1. The y is d sub y, which is -30 over d, which is -10. And the z is d sub z, which is 20 over d, which is -10, and I get -2. And I get 1, 3, -2. Again, can be easily checked by plugging them back in. It would have to work for each individual equation. So for a 3 variable, you know the elimination that we did in the first section, which you had to find the new 1, the new 2, and then go from there. Then we learned Gaussian elimination with back substitution, which was the ones with the zeros below. Then we learned Gauss-Jordan, which was the ones with the zeros above and below. And now we've got this. So you've got technically four different ways to solve a system with 3 variables. Obviously, test-wise, it will say use Kramers Rule, but final exam, cumulative test, anything that's like that, obviously you can choose.
What do you think is easier?
Depends on how good you are. I would either pick the very first one, the new 2, or this. Because individually, this is just a lot of multiplication. It's not a lot of, oh gosh, how do I figure out how to get this? I would try to avoid that Gauss-Jordan as much as you possibly could. But other than that.
What was the XYZ for this example?
The answer, you mean?
Oh, yeah.
It's 1, 3, -2.
Okay.
And then remember, these can be checked, right? Because we can do the system and then do reduce row echelon on your calculator, and you can find your answer. Questions on anything 7, 8, or beyond, or before, related. Because that marks the end of the new stuff. Yep.
Can you just review how you check it for row edge?
So when you plug it into your calculator, I would plug this part into the calculator. So it's a matrix that's a 3x4. You plug it into your calculator. You go to edit, do it with 3x4, type it in, and then underneath the math, underneath the matrix menu, there's an RREF, and if you do that with your A, which let's say that's what this is named, then your system would be 0, 0, 0, or no, 1, 0. It would be 1, 0, 0. What's my X? 1. So it would be. And then this would be, wait, no, I did too many. And then it would be 0, 1, 0, 5, 3. And then it would be 0, 0, 1, -2. That would be what you would get in your calculator from that. Yeah. You're welcome. Questions? All right, so I want you to finish out the assignment that you turned in this morning that only had the first section on it. You're going to finish it out and turn in the whole complete assignment to me for tomorrow. So there's a new assignment that just says 7.8. It doesn't say part 1. It just says 7.8. That's what you're going to submit the entire problems, all of them, to that assignment.